Welcome back to EFFATA Math, prepared by Dr. Bekalu Bitew and narrated by Ms. Yibela. In Lesson 3, we focus on expanding and factorizing expressions, essential skills in algebra, frequently tested in exams and applied across calculus functions and probability. Expanding means removing brackets by applying distributive laws. Let's look at some examples to understand this better. Our first example involves a single bracket. We have 3 multiplied by the bracket x plus 4. To expand this, we multiply each term inside the bracket by the term outside. So 3 multiplied by x is 3x, and 3 multiplied by 4 is 12. Our final result is 3x plus 12. Now, let's look at double brackets. We have the expression x plus 3 multiplied by x plus 5. To expand double brackets, we use the FOIL method. First, outer, inner, last. First x times x gives us x squared. Outer x times 5 gives us 5x. Inner, 3 times x gives us 3x. Last, 3 times 5 gives us 15. Adding these terms together, we get x squared plus 5x plus 3x plus 15, which simplifies to x squared plus 8x plus 15. Next, let's look at special products. First, we have the square of a binomial x plus 7 squared. For any binomial squared, we can use the formula a plus b squared equals a squared plus 2a plus b squared. So, x plus 7 squared equals x squared plus 2 times x times 7 plus 7 squared, which is x squared plus 14x plus 49. Next, we have the difference of squares, formula x plus 5 multiplied by x minus 5. For any expressions in the form a plus b multiplied by a minus b, we can use the formula a plus b times a minus b equals a squared minus b squared. So, x plus 5 multiplied by x minus 5 equals x squared minus 5 squared, which is x squared minus 25. Let's try an exam-style problem. Expand the expression 2x minus 3 multiplied by x plus 4. Using the FOIL method. First, 2x times x gives us 2x squared. Outer, 2x times 4 gives us 8x. Inner, negative 3 times x gives us negative 3x. Last, negative 3 times 4 gives us negative 12. Adding these terms together, 2x squared plus 8x minus 3x minus 12, which simplifies to 2x squared plus 5x minus 12. Now, let's move on to part 2, factorizing expressions. Factorizing is the reverse of expanding. We rewrite an expression as a product of factors. Let's start with factoring out a common factor. We have 6x plus 9. First, we need to identify the greatest common factor of all terms. The GCF of 6x and 9 is 3. So, 6x plus 9 can be written as 3 times 2x plus 3. Now, let's factorize a simple quadratic expression. We have x squared plus 7x plus 10. For quadratics in the form x squared plus bx plus c, we need to find 2 numbers that multiply to give c and add to give b. So, we need 2 numbers that multiply to give 10 and add to give 7. These numbers are 5 and 2, since 5 times 2 equals 10 and 5 plus 2 equals 7. So, x squared plus 7x plus 10 can be factorized as x plus 5 times x plus 2. Let's tackle a harder quadratic expression. We have 2x squared plus 7x plus 3. For quadratics in the form x squared plus bx plus c, where is not 1, the process is a bit more complex. We need to find 2 numbers that multiply to give a times c, which is 2 times 3, which equals 6, and add to give b, which is 7. These numbers are 6 and 1, since 6 times 1 equals 6, and 6 plus 1 equals 7. Now, we split the middle term using these numbers, 2x squared plus 6x plus x plus 3. We can factor the first 2 terms, 2x times x plus 3, and the last 2 terms, 1 times x plus 3. Now, we can factor out the common term x plus 3x plus 3 times 2x plus 1. So, 2x squared plus 7x plus 3 can be factorized as 2x plus 1 times x plus 3. Now, Let's look at the difference of squares. We have x squared minus 49. The difference of squares formula is a squared minus b squared equals a plus b times a minus b. Here, I was x and b is 7 because 7 squared is 49. So, x squared minus 49 can be factorized as x minus 7 times x plus 7. Let's try an exam-style problem. Factorize the expression x squared minus 2x minus 15. We need to find two numbers that multiply to give negative 15 and add to give negative 2. These numbers are negative 5 and positive 3, since negative 5 times positive 3 equals negative 15, and negative 5 plus 3 equals negative 2. So, x squared minus 2x minus 15 can be factorized as x minus 5 times x plus 3. Now, let's move on to part 3, applications in real problems. These skills are not just mechanical, they model real-world problems. Our first application is an area problem. A rectangle has sides x plus 3 and x plus 5. We need to find the area. To find the area of a rectangle, we multiply the length by the width. So, the area is x plus 3 multiplied by x plus 5. Using our expansion skills, we get x squared plus 8x plus 15 square units. Our second application involves projectile motion. A ball's height in meters is given by the function h of t equals negative 5t squared plus 20t, where t is the time in seconds. Let's factorize this expression to gain more insight. Taking out the common factor of negative 5t, we get h of t equals negative 5t times t minus 4. From this factor's form, we can see that the ball hits the ground when h of t equals 0, which occurs when t equals 0 or t equals 4. Since we're throwing the ball, t equals 0 is the starting time, and t equals 4 is when the ball returns to the ground. So, the ball hits the ground after 4 seconds. Our final application involves a profit function in business. The profit function for a company is modeled by p of x equals negative 2x squared plus 8x, where x represents the number of units produced and sold. Let's factorize this expression. Taking out the common factor of negative 2x, we get p of x equals negative 2x times x minus 4. From this factor's form, we can determine when the profit is 0, which occurs when x equals 0 or x equals 4. When x equals 0, it means the company produces nothing and makes no profit. When x equals 4, the company produces 4 units, but due to factors like costs, the profit becomes 0 again. The profit is maximized somewhere between these 2 points, which can be found using calculus. In this lesson, we mastered expanding and factorizing expressions, practiced exam-style questions, and applied these skills to area, motion, and business problems. We've seen how these algebraic techniques are not just abstract concepts, but powerful tools for solving real-world problems. In our next lesson, we will explore quadratic equations and graphs, a central idea that connects algebra to functions and calculus. Thank you for watching EFFATA Math.